Okay, so today we're going to cover the last section of Chapter 7, Section 5. Today we're going to talk about properties of trapezoids and kites. Now, one thing that you need to remember that when we start talking about these trapezoids and kites, these are not parallelograms. They do not have two pairs of parallel sides. And this is going to be key to remember. Okay, they are quadrilaterals, but they are not parallelograms. So let's go ahead and take a look at the definition of a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. If it had two pairs, then it would be a parallelogram, and a trapezoid is not a parallelogram. Each of the parallel sides is called a base. The non-parallel sides are called the legs. The base angles of a trapezoid are the two consecutive angles whose common side is a base. Now, one thing to look for is the two base sides are going to have the parallel marks. So a lot of times when you're given a picture of a trapezoid, it may not be sitting on its base. They may try to trick you and flip it on its side. So make sure you look for the parallel marks that will indicate which side is a base. Next, we're going to talk about isosceles trapezoids. Just like before when we had isosceles triangles, an isosceles triangle has two congruent sides. Here, the isosceles trapezoid are going to have two congruent legs. So if the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. Notice the congruency marks on the legs. Now, these are congruency marks. These are parallel marks. So the bases are not congruent, but the legs are. That's the congruent parts that make it an isosceles trapezoid. Next, we're going to learn three theorems for the isosceles trapezoid. We have the isosceles trapezoid base angles theorem, which states that if a trapezoid is isosceles, then each pair of base angles is congruent. We saw the same thing with the isosceles triangle base angles theorem. So if you're given that it's an isosceles trapezoid, then we know that the base angles are congruent. And here, in this first picture, angle A is congruent to angle D. These are both base angles. And then angle B would be congruent to C. The isosceles trapezoid base angles converse. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So now here, they're going to tell us that the base angles are congruent. Then we can conclude that it is an isosceles trapezoid. And then the isosceles trapezoid diagonals theorem states that a trapezoid is isosceles if and only if, and we could read this both ways, its diagonals are congruent. So the diagonals will only be congruent in an isosceles trapezoid. They are not congruent in just a regular trapezoid. So in this last one, we can see that diagonal AC is congruent to BD because it's an isosceles trapezoid. Next, we're going to learn about a midsegment of a trapezoid. So the midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So this is a leg over here. This is a leg over here. The midsegment is formed by connecting the two midpoints. So this is a midpoint, and so is this point. Now, these legs are not necessarily congruent. They didn't tell us this is an isosceles trapezoid. This is just for any trapezoid. But notice that the midpoint splits that leg into two congruent pieces. That's how I can tell that it is a midpoint. So this is just the definition of a midsegment. We saw the midsegment of a triangle. Now we're seeing the midsegment of a trapezoid. Next, we're going to learn the theorem, which is going to tell us how to find the length of the midsegment. The definition tells us how it's formed. And now the next slide is going to tell us about the length. Next, we have the theorem, and this is the trapezoid midsegment theorem. And the midsegment of a trapezoid is going to be parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So it's like an average of the bases. So if we want to add some variables here so we could write a formula for this, we could say that this one, and again, look for the parallel marks. So this is, we could say, is base 1, base 2, and what we can do is the formula would be base 1 plus base 2 divide by 2, or we could also memorize it as 1/2 the sum of the two bases. Next, we're going to define a kite. So a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So notice the consecutive sides that are congruent would be AB is congruent to AD. They're consecutive. They're one after the other. And then BC is congruent to CD. These are the exactly 2 pairs of congruent consecutive sides. Again, when you name a kite, you're going to write the word kite and then pick a starting letter and then go around the edges. So here they started at A, then they went to B, then to C, then to D. I could have also named this kite, and I could have gone in reverse, and I could have said A, D, C, B. It doesn't matter where you start, just go in consecutive order. Now a kite, it's just like what you would imagine a kite to be. If you went to the store and you bought a kite that you wanted to fly, that's the shape that a kite is. I know there's all different shapes of kites, but the traditional one would look like this. Next, we're going to learn 2 theorems, which will be properties of kites. Here are 2 properties, which are also presented as theorems. The first one states that if a quadrilateral is a kite, then its diagonals are perpendicular. Just like the rhombus in the square, diagonals are perpendicular in the square and in the rhombus. So here, the diagonals of a kite will be perpendicular. Remember, perpendicular lines form right angles. So all the way around, these perpendicular lines are 4 right angles, making 4 little right triangles. The second property states that if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. And the angles that will be congruent are the angles formed by the 2 non-congruent sides. So see how AB and BC, these are not congruent sides, and the angle that is in between those non-congruent sides, that will be the angle that opposite to that would be the congruent angle. A and C here would not be congruent angles. If we had 2 pairs of opposite angles that were congruent, then this would be a parallelogram. And a kite is not a parallelogram. So it can only be 1 pair of opposite angles that are congruent. Now we're going to do some examples. So first example. Now, again, notice this trapezoid is not sitting on its base. The bases are located where the parallel sides are. So here's my parallel mark. So my bases are AB and CD here. And this is actually an isosceles trapezoid. Notice the legs have congruency marks. Now, to find the measure of angle A, I can do this 2 different ways. But let me go ahead and maybe flip it over and let's see if that makes it a little bit easier to see. It should be the same. It doesn't really matter. But let me flip this over. C, D, and then 100, and then B and A. And then this was congruent, and this is parallel. Now, because this is an isosceles trapezoid, I know that my base angles here are going to be congruent. I also know that these are also going to be congruent angles because they're also base angles. So since these are both congruent, angle D is 100. Now, I know it didn't ask for us to find the measure of angle D, but it'll help us. This is one way where we can find angle A. Now, one thing we can do is we learned that all quadrilaterals, all four angles always add up to be 360. So I can add it in, or add the two base angles I have, the 100 plus the 100, and get 200. Then I could subtract that from 360, and I get 160. And then I could take the 160, divide it by 2, to get the measure of each of these base angles. So these both will be 80 degrees, which is the answer to my question. It's 80 degrees. I want to see the work, okay? So when you're doing the homework tonight, even though this is simple, I want to see that you're understanding the process, and I want to see the work for these. The only questions that you don't have to show work for are the ones that I'm going to ask you to classify the picture of whatever it is, if it's a rectangle or a rhombus. The rest of the questions, even simple like this, I want to see the work. Now, the other way that you could do this is realize that since these are parallel sides, you could think of the leg as being a transversal, and angles C and B are consecutive interior or same side interior, and they're supplements. So you could have also found, and this would also be a transversal over here. So to find the measure of angle A, all I really needed to do was 180 minus 100, and I get 80 degrees. So you can either draw the trapezoid and show me that you knew that these were parallel, and it's a transversal, and then just show me that you subtracted from 180. The next one was actually sitting on the base. Again, notice they're the parallel sides. So again, because it's an isosceles trapezoid again, I know I've got congruent base angles. So if this one's 49, so is this one. So now to find the measure of angle F, again, I can do it two ways. I could either show that I have parallel lines here, and this is my transversal, and then all I have to do is 180 minus 49, and that would give me 131 degrees, which is going to be the measure of angle F. That's one way to do it. The other way is, again, knowing that the four angles of a quadrilateral are 360. I could add 49 plus 49. I get 98. Subtract that from 360. This is the longer way, but it works. And then get 262. And then show that you're going to divide 262 by 2. And you get 131 as well. So you could use either method. But again, show me the work. That you're showing me that you realize that you have parallel lines and that they're consecutive interior. All right, next example. Again, another isosceles trapezoid. I know that I just learned a theorem that stated that the diagonals of an isosceles trapezoid are congruent. So I know that KJ is congruent to MF. So let me go ahead and label my picture with what's given. I am given that KB is 21.9. I'm also given that the entire length of the other diagonal is 32.7. Now it wants me to find the length of FB. Now, because these are congruent, I know that this piece over here is 21.9. Just this piece of this diagonal, not the whole thing. So then now to find the purple piece, all I need to do is take the 32.7 and subtract the 21.9. Yes. So then I'm going to subtract here, and I get 17.01. So FB equals 10.8. If you wanted to double check it, you should be able to add 10.8 plus 21.9, and it should give you 32.7, which it does. So you can double check that, because I know that the diagonals in an isosceles trapezoid are congruent. Okay, there's one more official example in the notes, but I'm going to add a mid-segment question just to go over it because it is on the test and it is in the homework. So let's go ahead and do this one first. So it says, in kite ABCD, the measure of angle DAB, which is over here.
Wait, Ms. Corey?
So the measure of DAB, which is this one right here, the whole thing, is 54. And then they're also giving me the measure of CDF, which is this one right here, and it's 52. Now, I know my properties of a kite tell me that I have two pairs, exactly two pairs of congruent consecutive sides. So that tells me that BC is congruent to CD, as well as AB is congruent to AD. I also know that I have exactly one pair of opposite angles congruent, but I'm not going to use that. But just so you're aware that these would also be considered congruent. Now, what I'm going to do, there's two different ways you can do this. Another property I also know about kite is the diagonals are perpendicular. So I also know that I've got right angles here. However, they're asking me to find the measure of BCD, and BCD is located up here. This angle right here. So what I'm going to do is I realize that right here I've got an isosceles triangle. And I know that my base angles are congruent. So this angle right here is equal to this one over here. So it's also 52. So now to find the missing angle, which is this one up here, I'm just going to add 52 plus 52. Get 104. Subtract that from 180 because it's a triangle. And my missing angle is 76 degrees. That's one way to do it. Yes. There's another way. Is I could work with a single little triangle here. So let's see, let me get another color here. So if I zoom into the picture here, notice I've got a small right triangle right here. And let me go ahead and pull that out. So if I redraw that, I knew that this angle right here was 52. This is a right angle, and I don't know this one. So what I can do is add 90 plus 52, get 142, subtract from 180, and then this side right here is 38. So I could say that this is 38, and because this triangle over here is also congruent, this side would also be 38. And then if you add 38 plus 38, you get 76. So either way, either treat it as the green isosceles triangle or work with it as a little right triangle. Now, if you're given a kite and there's no diagonals drawn in it, like you're going to do in the homework tonight, you don't need to make it into smaller triangles. So for example, if you just have a kite like this, that's a bad kite, but at least you get the idea. And let's say I have A, B, C, D, and again, they ask you to find the measure of angle A. And let's say I tell you this one's 40 and this one's 70, then what you can do is add 40 plus 70, get 110. I know that the four angles of a quadrilateral are 360. Subtract that. And then now divide that by 2. And each angle here, because these are congruent, would be 125. So the measure of angle A is 125. So don't be tempted to draw the diagonals in. Just use the fact that it's a quadrilateral. So let me add a slide here. So to find a mid-segment of a trapezoid, let's say I tell you that this is 10 and this is 18. All we need to do, we could say that this is base 1, this is base 2. I'm going to add 10 plus 18, divide by 2. I get 28, divide by 2, and I get 14. Okay, now, then the other way, let's say I give you the length of the midsegment. So let's say I give you this. And again, we can tell it's a midsegment because of the congruency marks. And let's say I give you this as 11.5 and this is 18.7. And it's going to ask you to find the length of AB. So let's see, M, N, D, C. So I'm going to, again, this could be base 1, this could be base 2. So 11.5 plus, and I could say this is going to be X. Divide by 2 equals 18.7. To solve for this, you're going to multiply both sides by 2 to get rid of the fraction. I get 18.7 times 2 is 37.4. And then I have 11.5 plus X. Subtract 11.5. And X equals 25.9. So that would be your midsegment. So this is doing finding the midsegment or also finding the length of one of the bases. We're still using base 1 plus base 2 divide by 2 or 1/2 base 1 plus base 2. Either way, you're using that formula and that will give you the length of the midsegment or to find a missing base.